Hello, this is Bruce Wildenmuth, and this is my project for AP Physics 1, and we are doing Newton's Laws, and it is by Bruce Wildenmuth and Edward Klein. Alright, first we're going to get a little rundown of the person that created these laws, Sir Isaac Newton himself. He was born on January 4th, 1643 in Colsterworth, United Kingdom, and he was schooled at Trinity College and Cambridge, so he's a pretty smart cookie. He was an English physicist and mathematician and was a key figure in the scientific revolution. And yeah, he excelled in calculus and much in math and helped a lot of people further the mathing world today through the scientific revolution. Alright, so Newton's first law. His first law states that an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So, basically, objects want to continue moving where they're already going. They just want to keep doing what they're doing. That means that if an object's at rest, it wants to stay at rest until something acts on it. Or, if an object is in motion, it wants to continue going in that direction with the same exact speed. And you can see by looking at this thing here, objects at rest just want to stay at rest, and objects in motion with a non-zero velocity and zero acceleration want to keep staying at the same speed. Newton's second law is for objects that are not balanced. It states that acceleration is dependent on the object's mass and the force acting on it. Therefore, as the force is increased, the acceleration of the object is increased. And as the mass of an object is increased, the acceleration of the object is decreased. And from this, he has derived two equations from this law, which is the net force equals mass times acceleration, or the acceleration equals the net force divided by mass. And 1 Newton equals 1 kilogram times meters per second squared. So if forces are unbalanced, there's an acceleration, and the acceleration directly pawns against the net force, and inversely depends upon the object's mass. And Newton's third law. This third law states that for every action, there's an equal and opposite reaction. That means that if I punch a wall, the force I apply to the wall is going to be the same. The wall is going to exert the same force back at my hand. Just like in this diagram here, the amount of force that he pushes on this wall is the same amount of force that the wall pushes back on his finger. Same thing with like the old trick question with a fly hitting the windshield of a car, which one exerts the greater force. They both exert the same exact force. And yeah, that's all. It's all about these third laws. Yeah. Okay, it's your man Bruce and Eddie Klein back at it again. This time we're going to do an interactive to show couple of these laws in motion. So the first law, which is back here, states that an object in motion wants to stay in motion with the same speed in the same direction unless acted upon by an unbalanced force. So if we just apply a quick amount of force, you will say 150. Anyway, you get rid of that force, you can see that the speed isn't going to change because there is no friction at all. So it's going to keep going the same exact speed through this whole thing because no other force is acting upon it. Therefore, Newton's first law, it's going to keep continuing in that same speed and same direction. Unless we apply a negative force to the left upon this box. So if we apply a negative 50 newtons to the left, it's going to start to slow down. You see the speed dropping because unequal force going up the opposite way. And now we're just going to reset that, and we're going to look at Newton's second law. Newton's second law is for objects that are not balanced. It states that acceleration dependent on the object's mass and the force acting on it. Therefore, as the force is increased, acceleration of the object is increased, which we can see here because it's not moving too quickly, not enough force. We increase it, it's going to start picking up speed. We increase it even more, going to keep going faster and faster and faster and increasing its acceleration. And that also means that if we increase the mass of an object, the acceleration is going to decrease. So if we just add, say, a 150, we drop a fridge on there. Anyway, let me get the speed up. So you can see the speed's increasing. We drop a fridge on there, it's going to start slowing down. We add another box, it's going to go even slower. It's going to decrease the acceleration a little bit there. So both of those work. And then we go down to Newton's third law. It states for every action there is an equal and opposite reaction, which we can't get on here. Yeah. Alright, we're going to show Newton's second law here with the more mass an object has, the more force it has, with this huge hammer on this guy here. So as you can see, the more mass is going to do that and crush him, but if I use this little sword with not as much mass, it's not going to knock him down or anything. It's just going to stay up, and it's not going to have as much force. My character can move quickly. The more mass you have, the more force it takes to move. It makes it heavier.